round-off error can cause some really interesting and hard to debug problems in Java code. So let's say that you are starting here in this code with a long type. So remember that long is a 64-bit integer. And so we started at just some really big number. Okay, so just some really big number. Then I have a double here, which I start at the same number. Now I'm going to walk through my for loop. I start at a particular position, and I walk through my for loop, and I add 1 to both the long and the double. Right? So I'm, you would think mathematically I'm starting with two variables with the same number. I'm adding 1, which is the same constant, to both of them. So it should never be true that L does not equal D, that the long and the double are never the same number because I'm starting with the same number and adding 1. But the long double type and the long data type and the double data type handle round-off error differently, right? So the long, when you add 1, will always be the exact integer until it actually overflows, until it gets to be greater than the max value. But the double will eventually, that 1 will be absorbed into round-off error and will turn out to when you have a large double and you add 1 at some point, that will be absorbed into the round-off error, and this addition of 1 will be rounded to 0. So at some point it will actually be true that the long and the double will be different numbers because the double, the loss of precision, the round-off error when you add 1 to the double will eventually cause it to become a different number than the long, even though you're adding both 1 to the long and the double. Right? So you have to watch out for this when you have very long, large numbers and you're comparing across different data types. You have to be careful because the round-off number is absorbed into the long and the double in different ways. Likewise, the round-off error, the absorption of round-off error, can cause trouble in checks of conditions in loops. So here we're starting a double with some really large number, and we want to loop until we get to some other larger number, right? And we say d++. But it turns out that this never terminates. This is actually equivalent to while true. Even though this doesn't look like it's equivalent to while true, it is equivalent to while true. And Java's not smart enough to figure that out. If you actually typed while true here, you would get a compile error saying, hey, you can't get there, or you can't get here. But Java's compiler isn't smart enough. So if you ever actually want to fool Java's compiler for some reason and still have this code here that you can never get to, you could do something like this, a calculation that the compiler can't do. It has to be done in runtime. But again, what happens is that because we're starting with a large number, when you add 1 to this large number, the large number gets rounded down to 0, and double never changes d, the value d never changes, and this loop never terminates. In this example, we're using a very large number for doubles, right? But it doesn't actually have to be that large a number for floats. So in bioinformatics, it might not be that you would ever, like if you're counting the number of sequences in a data set, you're probably not going to get to a number that's as large as this, right? But if you're counting the number of sequences in a data set, you could pretty easily get to 2 billion. So if you use the 32-bit floating point operator, this also never terminates as well, right? So the round-off error, even at modest numbers, a round-off error of when you add 1 to a floating point operator, floating point data type, it never it gets rounded down to 0. So this is also equivalent to while true. So again, you have to be really, really careful in using floats and doubles for these kinds of checks for conditionality. And it doesn't, 2 billion is not that big of a number in bioinformatics. We hit the number 2 billion all the time. And these kinds of bugs can be very, very difficult to detect or to figure out if you don't understand what's happening with these floating point data types.